slope is also referred to as the rate of change. Let's look at the definition of slope. Slope is a ratio between the vertical change and the horizontal change between 2 points on a line. Let's remember, on a line we have an x-axis and a y-axis. The y-axis is what's being referred to as the vertical change. So I'm just going to make a little reminder for us over here that this is the y-axis. And on the y-axis I'm going up and down. I'm going to refer to that as my rise. And then my horizontal change is referring to my x-axis, and because the x-axis goes left to right, I'm going to refer to that as my run. Now remember, slope can also be the rate of change. Between any 2 points, the rate of change or the slope should always be constant. Slope can be defined by the formula. It's a simple formula. Slope equals, and just remember, slope is also referred to as m. That's the variable we use to represent slope. Slope is the change between the vertical change. So I'm going to be looking at 2 points, so it's y sub 2 minus y sub 1 over the change in x. So that's x sub 2 minus x sub 1. Remember, we have to be consistent. The y's will always have to be in the numerator, and the x's will always have to be in the denominator. Let's look at an example of slope. I have the coordinates -2, 0, and 3, 3. I can plug these into the slope formula to find out what my slope is equal to. So slope equals y sub 2, which is 3. Okay, and once I use the number, I'm going to cross it out. Minus y sub 1, okay, over x sub 2, which is 3 as well, minus x sub 1, which is -2. Anytime I have a negative number that comes after a subtraction sign, I'm going to put it in parentheses. 3 minus 0 is equal to 3. 3 minus -2 is the same thing as 3 plus 2. Oops. Is the same thing as 3 plus 2. And that's equal to 3/5. So the slope between these 2 points is 3/5. If I were to graph these points, that means the distance would be 3/5. Let's see if that's true. If I'm going from the point -2, 0 to the point 3, 3, I am rising 3 units and then running 5 units. That is why I refer to my slope as rise over run. We can calculate it using the formula, which was 3/5, or we can look at it graphically and see if that's true. We're going 1, 2, 3, and then we're going 1, 2, 3, 4, 5. That is why my slope is equal to 3/5. Let's try another example. Now I'm given the points -1, 2, and 1, -2. Let's plug these into our slope formula. So we know slope equals y sub 2 minus y sub 1. Now either I can make this my y sub 2 or I can make this my y sub 2. Because this point comes first and this point comes second, I'm going to make this my y sub 2. So I have -2 minus 2. So I have -2 minus 2 over, now I have to come back to this point first, 1 minus -1. -2 minus 2 is equal to -4. 1 minus -1 is the same thing as 1 plus 1, which is 2. And I have to simplify my slope all the way. -4 over 2 can simplify to -2 over 1. And -2 over the 1 is the same thing as simply negative 2. Now, if I were just given this graph and I asked you to find the slope, I can count from my points, as you can see I have 3 points here, to see if that is true. When I go from this point to the next point, I'm down 1, down 2, over 1. If I'm going down, I represent that as a negative 2. And then I went to the right 1, so I represent that as 1, which is my rise over my run. Also, let's take a look at this. This graph is falling from left to right. Since it's falling down and the downward direction, it is considered to have a negative slope. So we can classify a graph just by looking at its picture to be negative as well.